Hey folks, Quill18 here, and welcome to a long overdue post-mortem of my Ludum 46 game, Promethean Legacy. Ludum Dare, if you don't know, is a game programming competition. I play in the 48-hour solo compo, i.e. the theme gets announced Friday evening, and you have until Sunday evening to build a game completely from scratch. No existing art assets, no music, no sounds, nothing like that. You can use any publicly available code libraries, including things like, say, Unity, for example, which obviously comes with some stuff right out of the box. Excuse me. I do stream the entire thing from start to finish over on Twitch. You can see the VODs over there, however, a great many parts of them will be muted because I require music when I program. And I don't want to wear earbuds for 48 hours straight, and there's not actually any way that I can sort of separate the tracks and whatever, because if nothing else, it'd get picked up by the microphone. As a result, YouTube hates these videos. I did spend the last couple of days trying a few different combinations of tweaks and changes and things I could do to get the videos up on the YouTube, but they actually get completely blocked. Not just flagged, but actually blocked and unable to publish them, unfortunately. So, yeah, if you want to watch the muted VODs, you totally can. I mean, they're not fully muted, but they'll be over on Twitch. Otherwise, let's take a look at this. What I want to do first is I want to do a little bit of playing in the game so I can talk about things. Now, one of the things that often happens after I finish Ludum Dare is there's usually some things where I'm like, oh, I wish I could have done this. I wish I could have done this. Graphically, this game doesn't look so impressive on the computer. However, what I was quite surprised at, because a few people had said, hey, this would probably go well on a mobile phone, is I did do a build on this for Android that I just tested on my own, and it is perfect on the phone right out of the box, and the graphic style actually works very well. Maybe not so much during this intro, although it's a little bit of a tutorial, which is great, but we're just going to go and skip through it and play the game itself. So the theme of this Ludum Dare was keep it alive, and so my interpretation of this theme was that we would be these sort of we'd be this village effectively trying to keep the sacred fire alive. We lose the game if the fire goes out, but really what it is, it's kind of a die rolling game. Every turn you will draw a quest from the pile, and you can complete the quest by putting the appropriate dice on it to meet the requirements, and then the quest will give you some sort of bonus. For example, you are guaranteed actually to get this as the very first quest. Hunt rabbits here. So it has 2 spots for dice, so we can drag in this and that, and they have to be equal to exactly 1. So we're going to put 2 1s in here. It's going to turn green to show that it can successfully complete. And if I commit, what's going to happen, the die in the target slot, which is the one with the word target over here, see, target gains 1. So this die here will gain 1 on this face. And if you watch it very carefully, it will change to a 2 here, boom, but then get re-rolled. Here's the thing, these dice, right, these are standard dice with 6 sides. These are all the values on each of the sides. So this die here was actually a 1, 1, 1, 1, 2, 2, but this 1 got changed to a 2 by that action, which is kind of nice. Oh, we got collective learning. This is a really good one to have early on. You have to use a value of 1 or lower. That includes these zeros over here, but all the dice that you use will gain 1, which is pretty amazing. So, I think I'm just going to turn a bunch of 1s into 2s, is going to be my idea over here. And then what I'm going to do, since I can't roll any better than a 2 on this die, I'm just going to put it on this obelisk here, just because it's going to save it, because any die that you have on a card isn't going to get re-rolled. So we're going to commit again. All these 1s are going to turn to 2s, and then we will re-roll. But that's kind of awesome. You can see here my fires are going down. So to if you end it, excuse me, if you end a turn with no fire in play, you lose the game. You can tend to the sacred fires. If you do, though, any dice that you use to tend to the fire will lose 1 point, 1 pip on that face. So what we'll do here is we'll bring the fire back up to 3, but it will sacrifice a pip on each one of those die. Unfortunately, on each one of those dice. Foraging berries, we need exactly 0, so we'll do that. I'm not going to bother with the rest, and we'll do this. So notice there's been this extra obelisk over here this whole time through. The way you win the game is by completing 4 monuments, and the monuments look like this, like the obelisk here. They don't have any requirements for the individual slots. Their only deal is that you need to total a certain number, so I need a total of 10 for the obelisk. It's, I think it's 10, 14, 18, and 24. So ultimately in the end, and if you're thinking about strategy for winning the game, what you kind of want to do is focus on getting 1 high value on each die, right? Because that 24, to do that one, you need either 6 dice with 4 points each, or 5 dice with 5 points each, or I guess 4 dice that are worth 6 points each. These are a few different ways to accomplish 24 or higher to do that. So having one die with like all sixes, I mean, means you'll always roll a 6, which is great, but doesn't actually help you complete monuments. So you really, I tend to focus on trying to generate one high face on each die. The other key strategy early on is try to get some 3s as early as possible. So if you have to choose between going from a 1 to a 2 or 2 to a 3, try to get some 3s early, because you're going to hit some cards early on that that require a 3. So I'm going to turn this 2 into a 1. I'll just use the 0 over here. I'll save this 2, because why not? And I'm not going to do anything else with the rest of the dice. Nap Flint, we can boost you as well. Well, I'll tell you what, this die here, 2 is the highest on it, so we'll try to make it into a 3. That seems okay. I'll do this. I'm going to save this 2 and this 2. You can see the total over here. This is the total of all the dice I currently have. So it's easy to tell at a glance if you have enough to complete your monument here. Here I do not. I'm going to be 1 short. I'm going to try to get away without tending the fire here, because I'm sort of gambling. A total of 8. That's too bad. Either we may have been able to roll high enough to finish the obelisk. If I'd roll another 2 or a 3 over here, it would have been possible to do it. And building a monument always resets your fires to 5, which is really good. So that's not going to be the case here. The target gains 1. Well, let's turn this 2 into a 3. Same sort of logic. We can use any dice over here. I'm just going to sacrifice one of these ones like this. You'll see there was a little note here that says warning losing. If I commit this, as soon as I put it there, it doesn't tell me I'm going to lose anymore. Okay, let's talk about this quest, because this tends to confuse people. Litany of Flames, as well as Light the Beacons, are a very interesting quest. If you complete it, then on this turn, Fire Tenders don't lose pips. So these 2 1s here, they will not decrease. Ideally, I'd like to put all 4 dice in here, but you need to have at least 1 pip on it to do it. So these guys will not lose a pip, so we sort of get a freebie here. Sort of a dead turn, but it's not too bad. Total of 6. Really want that obelisk to finish. Target gains 2, so let's turn this 1 into a 3. I'm going to save this 3. We'll reroll those 2. There's Light the Beacons, which I guess we're going to do. Now, what's nice about the Light the Beacons, you can use your 0s for this. And then after that, it doesn't matter. And I'll just put 2 dice in here, and we'll get 2 flames for free without losing any of our stats over there. Sacrifice. This is kind of cool. It sets the target to 0, gains 3 fires. You need to use a 2 or above for the target. The idea here is normally it costs you 1 pip for 1 fire. This costs you 2 pips for 3 fires. So it's slightly more efficient, although you don't, you gotta make sure not to use anything greater than 2 if you can avoid it. So here I could use a 3. It would set a 3 to 0 for 3, so it wouldn't really be a win. We're at 9. What I'm gonna do is I'm gonna bank these 2 3s. I'm gonna reroll. There's a good chance we can finish the obelisk next turn. Or maybe not. I don't know. I think what I'm gonna do is I'm just gonna go and tend 1 fire to retain it and not lose. There we go. We've got a total of 11. So we can go this and this and this. There we go. That would complete this, which will give me 5 fires. This is going to give me 5 fires when we complete this. I don't think there's any sense to kind of save or do anything else with anything else. Actually, I could go and Blessed by Flames, because the target will gain 2. I'll lose 1 fire, but I mean, I'm still going to be okay here. So I will commit to this. So we've completed the monument. Now we have to build the henge at 14. This also added more cards to the quest deck over here. By the way, 4 cards here, so 1 monument plus 3 quests is the max. If ever you get stuck with 3 quests that are really not good for you, you can pray. Pray discards all the quests and draws 1 more, although it also costs you 1 fire, same as doing the commit over here. So this is your reset quest button, is kind of the idea. Anyway, and that's it. It is, the challenge is, maybe how many turns will it take you to beat the game? It is certainly possible to sort of get stuck and lose. It's fairly uncommon to lose outright, but it's fairly common to feel like you're constantly on the edge of collapse. And because what you're trying to do is you're really trying to minimize how many dice you feed to the fire directly versus getting, more efficient plays. Like, sacrifice wouldn't be too bad, for example. Like, this might be an actual opportunity to go ahead and do the sacrifice. So it'll boost us up to 3, so that'll bring us to 6, which technically is over the limit. But it doesn't get clamped until right at the end of all the calculations. So it'll bring us to 6, but then we'll lose 1 fire from just the end of the turn, which brings us back down to 5, which makes us a perfectly efficient play. No problems there. Display a skill, by the way, is one of the cards that is a reason why you do want to get some 3s fairly quickly. because you need a 3 and above for the bottom part of this card. So having access to some 3s can be pretty valuable. So we're going to be sitting at 5 fires, which is very comfortable. And there you go, we got some 3s, although I can't finish it. But what I could do is put a 3 here, put a 3 here, just bank that. Well, actually, I may as well hunt some mammoths. Maybe I'll save one of these 3s, and I'll use the other one. Let's turn this 3 into a 5, which is spiffy. See, the 5s have a different color. Oh, we still can't rain dance. That's too bad. But we can do a nice display of skill and a few other things. Fertility rates I like. It's sort of like we're making a baby. The most efficient way to use this is to turn a 0 into a 2, which turns this all into a pretty productive turn. Anyway, all right, that is that. Promethean Legacy. So let's open the main scene, and we're going to talk about sort of, how this game was actually put together, as well as some of the things that went really well and some of the things that went really poorly. So, with the 48-hour solo, my standard schedule that I look at is, so at Friday normally at 6 p.m., or sorry, 9 p.m. Eastern Time is the time for this one. 9 p.m. Eastern Time is when the theme gets announced. And usually, I allow up to 1 hour to try to come up with and decide on what the game will be. So from 9 to 10, once it hits 10, I'm locked into, okay, I want to lock into an idea and start coding. But I allow up to an hour to sort of think about it, and which has worked out really well in the past. It's a good way to sort of like kind of standardize things and whatever. As it turns out, this time around, I locked in, it took about 5 minutes to decide on the core idea about this. And I made a little sketch in Photoshop that is basically this layout, more or less. It only took about 5 minutes, and I still went for about an hour before I think I started programming, but it was basically working out the mechanics of this game. I'd already decided effectively on the core game, and it was mostly just trying to figure out how the mechanics of it will work. And so that the schedule works really well. And then usually what I like to do by the end of Friday is have a vague sort of idea of a prototype, like, some mechanics that work, and sort of confirm that, like, oh yeah, this could be fun. And then what I always say is Saturday morning, I allow myself Saturday morning when I get up, I'm allowed to change what the game is. If I've slept on it and I said, you know what, this is no good, then I can go ahead and just make some changes to, sorry, my chair was stuck. I was like, I know my voice was hitching there. I was trying to move my chair a little bit and it wouldn't because it was rolling on something. But all right, disaster averted. And I've done that a couple of times, I think, where I've abandoned the game on Saturday. I think literally twice, and both times it worked out really well to have done so, which is wonderful. But here, I was pretty happy with everything. So that was good. In terms of programming, we're doing something that is basically completely user interface driven. Sometimes it can lead to a few little gotchas because some things, when you're working with user interface, and it doesn't matter what language, what environment, whatever that you're working with, it can always get very, very, very fiddly. And I was worried that, because usually the way it works in Ludum Dare, so it's 48 hours, but I do sleep and I take break for walks and for getting some food and that sort of thing. I think effectively we average about maybe 32 hours worth of programming, somewhere around there, which is still pretty good. But inevitably, there's usually something that kind of sticks us up, where this one stupid minor thing costs us 1, 2, 4 hours of time sometimes. And a lot of times it's something sort of in the user interface, especially when you're doing sort of drag and drop kind of things. It can be really fiddly to get it to the point where it feels quite correct. There's that. Also, when you're working with the user interface, sometimes you're having to deal with the gotchas that happen from different screen resolutions and various things like that. For example, with the canvas here, what we did is we did go with the canvas scaler, which is really nice because then it allows the scaling by screen size, as opposed to keeping all the pixels in 1-to-1 ratio, which is nice for user interfaces where you want pixel perfect interfaces, where each pixel is exactly where it's supposed to be on everyone's screen. But it doesn't mostly cover up the screen. On people with very high resolutions, those screen elements might look a little smaller, and if you're low resolution, the screen elements will look a little bit bigger, but they'll always be pixel perfect. That is not what we wanted here, because our user interface covers our whole screen, and if we set this to constant pixel size, then as the screen changes, all it was doing is sort of clipping the bits, which is not what we're looking for. So what you want is scale with screen size. You give it a reference resolution, so these numbers in a sense don't matter. All I have to do is put in something based on the sort of screen ratio that I'm targeting, which is 16:9, which is your standard sort of widescreen monitor, right? Your 1080p or whatever. So you put in just some numbers that come out to 16 by 9 over here, and by default, I believe it matches the width over here. So as the width changes, it does this. So this covers your case of if someone's running on a square monitor, right? If they're on a 4x3 monitor, or they've got some sort of vertical orientation kind of thing, it'll still be okay. But what it doesn't work for properly is if someone is running an ultra-wide monitor. Like this. So in an ultra-wide monitor, it starts clipping the top and the bottom. That's not a problem if you set this to height. That's great, but then again, if you go to a squarer monitor, which includes the very common 16 by 10, which would look sort of like this. Playable, but looks stupid, and if you were to try 4x3, it would look really bad. So the solution to that is you write a tiny little script over here. We're going to look at the code for the very first time here. This little fixed canvas ratio script, it just runs at the start of the, when you launch the game. So this is our reference ratio, the 16 by 9. Then we figure out what their actual ratio is, and we figure out if they're more square or more long than our reference ratio, and we just set the width or height value to match that. And that solves that. Really, if you're going to do anything with user interface, 99% of the time, what you want to do is you want to use the canvas scaler with scale with screen size. 99% of the time, this should be your first step, because by default when you set up a canvas, it has constant pixel size, but in almost every situation, you probably want some sort of scale with screen size kind of thing. The other thing that I like to do is then under my canvas, I make my so-called safe area over here, which is just an image that doesn't even render. It has no sprite or anything like that. But I set this to the so-called reference resolution, so the 1280 by 720, because there's nothing that stops you from putting things outside of this. This canvas scaling determines the scaling of the canvas. It doesn't set up any sort of limits or restrictions. So there's no reason that the UI system won't let you draw things outside. But often that's not what you're looking for. So I like to make this one safe area like this of the size that I'm targeting, and then everything else belongs to that and just, obeys these restrictions. And then it just stops you from making mistakes. It's not required to do this, but it makes things just a lot easier in life. I don't even think you need the you don't need the image here. I think I had this because for a while, I guess I do set a bit of a background color with it. I guess I do use it to do something. That's right, because it doesn't need, the safe area can be an empty. And in fact, I think normally I just use an empty. I'm not going to go through all the code. Most of it is actually fairly decent. We can look at something that went kind of dumb. The end turn button over here, which is called commit. It ended up having a lot of code in here. Because this end turn button effectively ended up being a lot of my game logic, and calling this class end turn button is silly and incorrect. Really, this could be something like the turn manager or the game manager, or just some sort of end of turn function. And when you click the button, it should call something on this script, but the script shouldn't be called end turn button, and it shouldn't live on the actual end turn button GUI object. It should probably have been just another one of our sort of empty game objects that are just lingering around, or just here to absorb some stuff. It is worth noting the quest deck and the monument deck. There's another kind of silly deck hack in here, because their functionality is 99% the same, except one shuffles and one doesn't. And there's a couple other little tiny tweaks in there. So I do have this check mark in the code, for a Boolean in the code, for whether or not this deck should get shuffled. But we check this a few times for logic related to the difference between the quest deck and the monument deck, which is a little bit hacky and cheesy. So maybe shuffle deck should just be called, whether it's the monument deck or not. Or in practice, I think this would have been a good case where the quest deck script over here, which actually isn't as long as I thought it was. I thought it was much bigger than this. This quest deck script over here, probably we could have subclassed it as just sort of like a deck script, and then subclassed a quest deck versus monument deck with just a couple of changes here and there. But it wasn't very significant. It is one of the things that was been the great development in game development, as well as general app development, is recognizing that this component-oriented design is way more convenient than strict sort of subclassing kind of design. But there is some opportunity for subclasses from time to time, and I think this would have been one of them. But in the end, didn't really cost us too much. But it does look a little funny if you look at the code for references to shuffle deck. Yeah, right over here. This is our hacky way of detecting the monument card. Is that really all we do with it? Okay, I thought there was another one. I guess actually there is another one over here, because if this is what happens if we run out of cards in the deck, we reshuffle it, or we must be the monument deck. So again, this is a bit of a hack, and then we show the victory screen. So again, checking on that makes it really hard to like review code later on. But the thing with Ludum Dare, you do want to start with a fairly decent code structure as early as you can, because it will save you some trouble. But because you don't have the ability to sit and like diagram all your classes right away, because really you're sort of still designing the game as you go, and there's realistically no other way to do that. And as a result, at a certain point, you have to just say, all right, it's terrible sort of code, but we just have to keep going with it because of the time. What helps is because it's only 48 hours, and because you're the only programmer on the project, it's actually fairly easy to basically have all this code uploaded into your brain the entire time something is happening. So like when I'm testing the game and I see a bug, I know exactly, generally speaking, most of the time, I know exactly where I need to go to correct that bug, because all this code is kind of running in my head. I can like kind of close my eyes and sort of do debugging step by step for most of it, because there's not that much code, because it's not the world's biggest project, because it's only 48 hours, and because it's only me. Obviously, if it's a team project, that's not really going to work out, because the code is going to be like very difficult to follow for another person. And also, if I come back to this a year later, I'm going to have no idea what's going on. So, you know, it's not like you end up with good code in your Ludum Dare project, but you really have to kind of work that line between the two. I'll also note there's this fire text script over here, which is unused. It doesn't actually get used. This is our title thing. I wanted to make like fiery letters for the title, and this was the first attempt. It was sort of just cycling between different colors, and I wasn't too happy with it. So I ended up doing something. I mean, it doesn't look good, because the problem is I'm not an artist, right? It's a huge problem for some of these games. Oh, I fiddled with the canvas. That's what it is. And yeah, this title doesn't look that great, but you can see these sort of fiery effects here. It's done, and you can take a look, of course. It's not slideshow. Oh no, it is in the slideshow, because this is the first slide, the title screen. The way I did it is I just have the same text set twice, but once it's set to outline, so it doesn't actually render the image itself. It just does the outline in black, so just the black outline, and then the other one, it renders the image, but then it gets masked. So the mask makes it so you don't actually see the letters that are rendered here, but it is used as a mask, as a filter for the image behind, which is just this thing here, this sort of like clouds effect that, you know, I think it's just per-line noise. And then all I do is I cycle the UVs and things like that. It was fine. It was fine. I'm not going to say it was brilliant, and I was super happy with how that worked out, but it was okay. But yeah, I feel like when you're playing, like, if this was a PC exclusive release, obviously we could add a lot more art and style. Some people did some really cool mock-ups of cards after the fact for the quote-unquote Steam release. But the thing is, again, once you get this on your phone, it's kind of perfect. Especially with me, I've you know, on a small screen, a small phone, I have a hard time necessarily seeing all the details all the time. And this just came out feeling really sort of clean and easy to follow. And I think I am planning on doing a proper phone release. On probably Android. I'm going to clean up a few things and change a few things before I do, but my hope is to do it. One of the things I want to do, right now the only way to move dice is to click, hold, drag. I want to change it for the phone to just, you can click on a die and then click on a target, which shouldn't be too difficult to do, and I think would go a long way to making things a little bit neater. I might do some options, like to turn off the particle effects, and maybe over here too, just, you know, turn off this particle system. Not that they're very expensive, but we'll do that. A couple of things I want to change to the user interface as well. So like when you get to the point where you would lose your game. So right now, if we hit commit, we would lose. Instead of the warning being here, I just want to make it so the entire button turns red and the word commit changes to like lose game or something like that. Makes it that much more obvious what's going to happen if you were to just continue. But yeah, I don't know. One of the things, again, this is sort of an interest of speed and not mucking around with too many things and different systems and things like that. The quests right now are, the quest deck thing is just a Unity sort of object, you know, mono behavior attached to an object, and I just exposed it here where you can tweak things. You could use scriptable objects and different things like that as well. Arguably, scriptable objects might be slightly better than just doing this, and it probably would. It would be better, especially as this gets a little bit bigger. But it's still only slightly better. Really, what I would do is the card definition. What I would do is just move it to like a JSON or an XML file or something, and read that in. That is the more better. Going from this to scriptable object is probably a little cleaner, but not in any meaningful way that was worth me fiddle-faddling with. And the correct solution is actually to just do like parse an XML and JSON file or something, and that would have taken too long for this. But it's always a bit of it's always interesting because you're always having to balance out, okay, how much time will implementing the system save versus how long will it take to implement? And I mean, that's true on any project, really. And it's true even outside of programming, right? But especially in a time-limited game jam like this is, okay, if developing an XML reading system for this stuff would take me an hour, 2 hours, would that save time in the end, both in terms of developing more cards, but also maybe debugging problems and different things? And in this case, I think the answer was a resounding no. But I think as a long-term thing, it would definitely be a yes, especially that it would be easier to, alter and maintain the game, and to allow a game designer to come in and work on the project without having to mess around with the code. That sort of thing would be kind of spiffy. So, but in the end, I still think this was, I think this is probably the correct decision in terms of making the best use of time. Although Unity does complain because there's sort of nested things, because each card has the ability to add more cards to the pool. That only comes up from the monument deck. So when you complete a monument, it adds more cards to the deck. So when you build that first obelisk, it adds the Forge Metal and Hunt Bison to the quest deck over here. So Unity complains because it's like a looping serialization thing, just because of the way we did it. And it doesn't actually come up to be a problem in any way whatsoever. But technically, you can't nest more than 7 cards deep. There might be a way to like disable that message, or there may have been another way to do something to do it, but it had no impact on anything. So I was like, who cares? What else? Oh, we can make a little note, like, why are there 2 cameras in this scene? So that's kind of interesting. By default, so the thing is, the user interface here, the canvas by default, basically the way it works is your camera renders all your 3D or 2D objects, right? So all your 3D models, all your 2D sprites, all of that gets rendered. And then afterwards, the UI gets splatted on top of your screen. In fact, that is literally the default way it works, because the default canvas mode is screen space overlay. And so what happens with this is your entire screen gets rendered, and then it splats the user interface on top, covering everything up. Notice we don't see any flaming particles over here. Now, particles, the default particle system is a 3D thing. It gets rendered in 3D, and it happens before the UI shows up. So as a result, basically the particle effects get rendered, and then the UI gets splatted on top of the screen. That's screen space overlay. With screen space camera, what happens instead is it's pretty similar. The camera renders all its 3D and 2D stuff, and then the user interface gets splatted on top of what the camera renders. But then if you have more than one camera, the second camera gets a shot afterwards, and that's what's happening here. The main camera technically renders everything. What I should actually do is tell it, like, don't even bother, don't bother rendering anything but the UI, which would save a microsecond of processing time. And I should do that. I'm worried about messing with it right now, but so what I kind of do is I could say, don't render anything literally except the UI. So main camera becomes UI camera. And it goes first. So the UI camera goes first. It renders all of its normal stuff. In this case, it's nothing. And then it renders the user interface, which is fine and everything. And then after this camera is done, then the particle camera takes over. And the particle camera, its only job, first of all, you have to set the clear flag so don't clear. We don't want the particle camera to blank out everything and start all over from scratch. That would be pointless because it would lose everything it had already rendered. And then all it does really is, because it's not the target, with the canvas, since we set the camera, screen space camera, it needs to know what camera to render on. So then the particle camera just renders everything in 3D and 2D, but doesn't render the UI, which puts the flaming particles in front of it. We could have also done this if the canvas existed in world space. Sorry, not there. World space, and then what happens, the canvas would actually just effectively be a 2D plane in 3D space that you could move around and everything. It's great for graphics, like if you have a game where you want like little name tags above people's heads, or even if you're doing like a 3D first-person game and there's like computer screens around, each one of those screens could just be a canvas in world space, and it looks really cool. And we did do an iteration where we messed around with the world space thing, but then that really, because of that, because it's just rendering in the world, it really doesn't know. You can't do canvas scaling because it's completely independent of anything that's going on with the screen dimensions. So it was not the correct solution. The correct solution was the dual camera solution, which was really, really, really easy to do. And yeah, I'm going to save that actually because I like the idea of changing the culling mask on this UI camera. I think that's a lot clearer about what's going on. We know about the sound, so I can't do music. I have done music for some games before. I've used various procedural music generation things and different stuff like that, and sometimes I've actually been quite happy with what I've ended up with. But generally speaking, I'm bad at music. And you got to know your limits. I mean, you got to know that in life. It's important to know what you're good at, but it's most important to know what you're bad at so that you can think of the best ways to work around those kinds of issues. One of my old bosses told me that, and I thought, that's a really good way of thinking, and I've kind of incorporated that into everything I've done since then, and I found it really helpful. So I know that I'm not great at music, so always with Ludum Dare, one of my things is, all right, how do we get around this issue? I like making sound effects, but not music. And so what I've done a lot of times with a lot of my games is, rather than include music, I just try to make sure there's lots of sound density from the environment and different things like that, there's not just blankness going on there. And so there's still kind of a good presence of various sounds and things like that, which works well in action games. You just have lots of like explosions and enemies making noises and bullet firing and things. You don't notice the lack of music. But this doesn't have any of that. So instead, and this is the first time I've done this, I created a variety of different little sound effects and various loops and things like that to play in the background. Let me just shush for a sec. So as you can see, what's happening is there's just some various sounds that are playing in the background. I've got the same code twice. So I created the sound generator code or script, and I have two versions of it. Well, the same script, but I have two of these objects in here: sounds long and sounds short. And that's it. And then I can tweak how many clips that it can play at the same time. What's the average delay between starting a new clip? We could also change the individual volumes of these two, so the short sounds are actually playing at half the sound. And there's more short sounds, but there's bigger delays between them. So there's fewer long sounds. Most of it is just sort of wind and things like that, just environmental stuff. And I'm not going to say that this came out like perfect or wonderful, but it's pretty good. It gives you a bit of a sense that you're kind of in a village, I would say. And as you add more and more of this, it works well. And honestly, there's no reason you can't do this and have music. If you are someone who can do music, do that, but also put in random environmental sounds. And this is not just for like sort of UI-driven, dice games like this, but this is a good solution to, when you're making the next Skyrim or something. When you walk through a village, you want it to feel alive. Well, it has to sound alive, which is part of that. So I was pretty pleased with how that came out in the end. I thought that was a good way to avoid some of the issues I often have. Plus, it was mostly a really good excuse for having the fun sound effect days. It's one of my favorite things to do in Ludum Dare. Always really popular on stream to just start doing a bunch of sound effects. And so that still let us do sound effectsy things, even though this wasn't a very sound effecty game, right? Other than like picking up and dropping the dice, there's not a whole lot to talk about in terms of sound design. I think that's kind of it as a bit of an overview for the code. Again, I mean, we could look through different things. So the dice certainly get a lot of work to, they do a lot of work for us. So this is all the code that belongs to the dice. The big thing is they have 7 sprites, right? They have the numbers 1 through 6, as well as a blank sprite. So we know those, all 7 images. And then what we do is we have an array of, it's an array of 6, right, one for each side, that just tells you how many pips, how many points are on each side of each die. And then we keep track of which die is up. And then what happens is anytime for some reason the value of the die changes, we update the image. This update image over here, so we find out, okay, how many pips are we showing? is for some reason we do check to see if like if we ended up like, oh, this die is supposed to have 9 pips on the side. No, you can't do that. That's not allowed. Otherwise, what we do is we just set the current image to the image that matches the number of pips. So this will be 0 through 6, and that's the order of the images in our array. So if number of pips is equal to 4, this is going to be the image that's got the 4 dots on it. So we just set the sprite to that. Easy peasy. And some of the sprites are colored. As you go into 4, 5, and 6, they become progressively more red to show that they're super intense, or I don't know, something about the God of Fire, something like that. Click and drag sort of logic. Over here, okay, this is something that I just started working on this for the click and click sort of placement as opposed to click and drag, so ignore that. But basically what we did, and there's a bunch of ways to implement clicking and dragging, but what I did for this object is I have it implement the begin, on, and end drag interface. To implement that, it does require that you have functions that look like, there you go, begin drag, on drag, and end drag over here, like that. And then these will get called when the user interface gets those things. So this interfaces with Unity's event system for this iteration of the UI system, because there's about 30 different versions of the Unity UI system, because why not? But anyway, over here, so all we do is when we begin drag, this gets called the first time. So the user is holding down the mouse and has just moved the mouse slightly. This gets called the first frame that happens. What we do is we unparent ourselves from before. Unparent actually does a couple of things, because it removes ourselves from the die slot. We parent ourselves just to the canvas as a whole, and then set ourselves to be the last sibling. This guarantees that we will be drawn on top of everything, because otherwise what could happen is as you drag the die, it might show up behind certain elements and look really weird, or just become basically invisible as you're dragging it, which would obviously be kind of poor over there. So when the drag starts, we unparent ourselves, and the stat block, which are the numbers to the left of the die. Where's my Unity window? Right over here. The numbers here to the left of the die, we just hide that while you're dragging. That's all. And then while we're dragging, so this gets called every single frame we are dragging things, all we do is we move with the mouse. There's a couple of different ways to do it. I ended up doing this way. Basically, I'm setting the sort of Unity space, like world coordinates for the mouse, as opposed to doing sort of parent level stuff, but this works fine. We cache the old Z index because I don't remember, we may not actually need to do this anymore. Most of our objects should all be on the same Z index, so this probably isn't strictly required, but there's a few cases where some weird things might happen if we didn't do this or whatever. That may have been earlier in testing. That may have been before I changed some of the parent stuff. I don't know. I'll have to do a pass and a test. I'm not sure this is required, these 2 lines, but we'll see. But yeah, basically what I'm doing is the point where this is where our mouse is, I'm turning that into world coordinates, and then just setting our world position to that over there, and then end drag. So this does a little bit more. So this is when we release the mouse. What we're doing is we want to find out if we're on top of a valid die slot. So a die slot, which is, you know, this script over here, and is these sort of empty squares like this, places where you can drop a die. So what we're doing is wherever we are, so we are where our mouse is, we are doing a raycast into the screen to find out. This is going to hit every single UI element beneath our mouse. So it'll hit the die, it'll hit, you know, the background image, it'll hit whatever, but it'll also hit die slots. So we do a raycast into the screen under our mouse, and we loop through every result, everything that we hit. And on each one of those, we try to grab the die slot. We do get component in parent, as well as get component in children. They both check the actual object itself first. So if the die slot belongs on this hit object, it's going to be there. But one of the big things, and I always tell you this, whether you're working in 2D, 3D, whatever, you should always have all your visuals as a child of sort of the prefab itself. The parent of your, like the root object of your prefab should basically just be an empty, although you probably want all your script logic on that. By having the graphics, the collision boxes, the 3D meshes, the whatever, be a child of this otherwise empty game object means it's really easy for you to swap visuals in and out, or to tweak the physics, or like the physical, like the collision boxes of things, which the collision box is usually linked to the visuals, right? The collision box should basically match what the visuals of your object are. That lets you do some good stuff. So here, when we are hitting with our raycast, the actual thing we hit, which would be one of these images in the UI system, it may not actually be the game object with the die slot code on it. So we do a get component in parent just to make sure that everything's okay. So if we change and fiddle faddle with the layout of that prefab, which I mean we could take a look at, what does the die slot prefab look like over here? It is indeed that is the case. So you can see here the object itself, the die slot itself. All it's got is the die slot script on it. That's it. And then beneath that it has the image and potentially text and things like that. So this is, in this case, to get this to work correctly, we did, in fact, need to do the get component in parent. Then what we do is we just check to see if there's actually a die slot on this. If it's null, I mean, I could have fiddled it around. I could have said, if ds is equal to null, then continue to the next loop. Might be I usually favor like early exits, but here anyway we just check if die slot is not equal to null, then we did release the mouse on top of a die slot. So then we just make sure, is it actually legal for us to drop a die in here, i.e. this would return false if there was already a die in that slot. This would return false if it needs to be a 2 and above and you're holding a 1, that sort of thing. So those would return false and not do it. If it is legal, then we attach ourselves to that slot and then we play a little bit of a sound effect. Excellent. And if we get all the way down here, it means we did not drop the die on a legal die slot. So what it does is it returns the die to its origin, which is its box over on the left-hand side. So yeah, that's there you go. You can see some is legal for a slot. Some of these can be done with a switch. Some would be not as quick. Here you could do a switch on the target type, but then you'd still need to do an if for some other things. So anyway, people always argue. Honestly. I think that most of the time switches can lead to more sort of code confusion than anything else, especially with like the breaks and the fall throughs and different things. But anyway, 6 of one, half dozen the other in this case, I think. Touch a slot. We've used a few coroutines. I'm personally not a fan of coroutines, as anyone who's ever watched me will know, because it sort of fakes asynchronicity, like as a multi-threaded thing or this or that or whatever, but in, like semi-weird, unpredictable ways, and also, there's always the possibility of timing issues, whether you're doing things multi-threaded or not, in the sense that, other code is running while the coroutine is still doing something, and every now and again you might find yourself in a situation where you're expecting something to be in a certain sort of deterministic position, but it's still executing some coroutine somewhere along the line. So anytime you do anything that's got kind of this asynchronistic logic, whether it's coroutines or threading or whatever, you can kind of find yourself in a bit of a hole. But this is the easiest way to handle some of the animation. So this lets you smoothly move the die to the slot. So when you release the die wherever, it doesn't just snap into where it's supposed to go. It sort of smoothly moves over there. Die slot over here, so it's just the target for dropping our dice. It handles like updating its text over here, and it's got some logic as to whether or not you can put dice in here or not. There's also this fire slot code over here. So this may have been an example of, we could have subclassed the die slot with fire slot, but effectively this component play comes out to about the same. And honestly might keep the code slightly simpler because you're not sort of, calling the parent version of a function and different things like that. You just sort of cross-link. So these, the fire slot code, this is specifically for the, these 5 slots down here for the sacred fire. And so it needs a slightly special code because mostly it changes some of the logic with whether something is occupied or not. Because if one of those die slots is on fire, it counts as sort of being occupied, by virtue of it's on fire, even if it doesn't have a die. So again, that could be a good subclass example, but this worked beautifully. So you know what? Screw it. Good enough. The Ember stuff, that's just the sort of sparks in the background. These are just purely visual effects. Nothing much to talk about there. Fire slot manager. This is responsible for knowing what level of the fire is, and basically what it does is it turns the fires on and off to match the correct level of the fire. That's about it. A little visual thing over here, the little warning that you're losing thing. UI thing to keep track of the monuments. Typically when I code, I actually like to have anything that's just literally a script that belongs on the user interface. I often like to precede it with just UI underscore. It makes it really clear that it's not kind of game logic. I mean, folders and stuff are good too, but even if I have like a separate folder from my UI driven code, I usually still do the UI underscore thing because I find it makes it a lot easier. When you're just trying to track down a gameplay logic bug, you can just sort of go through each script here with the certainty that basically you're only looking at game logic kind of things, which is clearly not the case here because some of these are just visual things. The pray button is the thing that wipes out all the quests and resets them. raw image UV cycler. This is used to do that little flame effect in the background. The sound generator, I think, is quite spiffy. I like doing stuff like this. Yeah, I don't know. That's about it. So in the end, it's funny, like, you know, you spend so much time doing things and changing code and writing and rewriting code, and in the end, it's like, it's surprising how little code it takes to get things done. Again, a shocking amount of logic is on this end turn button over here. This is so much more than I want. Also, this one function is very long. Usually, I say as a rule of thumb, your function shouldn't be longer than one screen, so that you can see it all at once, and that would certainly be a good idea here. The click coroutine should probably have just called other subfunctions and things, but, you know, sort of grew organically, and then, you know, then we were just there at some point. So, done and done. Anyway, that is a little bit of a post-mortem look at my Ludum Dare 46 game, which is currently called Promethean Legacy. Although what I might do is I might invert the names here. I might call the game Fan the Flames, and then as a subtitle, Promethean Legacy or something like that. That might be a little bit more catchy. We shall see. I do have... Here's the thing. Because it had been a while since a programming video, I actually recorded this. I think this is my 4th recording of this, and I've just never been happy. And you know how it's like, if something has been a while, then when you want to get around to it, it's like it's got to be perfect. You've got all this extra pressure on yourself. So this took a while to get to. Partially also, I was dabbling around with trying to get the VODs from the Twitch up on YouTube, but I just can't get YouTube to ignore all the music that's in there. And again, programming without music, just being blasted out loud, is simply not an option for me. It is part of the mechanics. I am working on another tutorial of actually, again, I started working on it a couple months ago. I've thrown it out twice, so I'm going to probably start a 3rd time on the exact same tutorial. I should probably just do it as a stream so that, like, well, I guess this is the take. F it, we're doing it live, right? Exactly. But we will see. So I'm hoping to get more content up on the programming channel soon. My apologies for the delay between these, but I really do want to get some more, so hopefully that's it. And thank you, everyone who came out to my Ludum Dare weekend, and also congratulations to everyone else who participated in Ludum Dare as well. I hope you had a lot of fun. I think it's really, really satisfying to do, and I definitely recommend that if you get a chance to do a game jam, you should do it, because it is unbelievably motivating. Thanks a lot, folks. See you next time. Bye-bye.